So now that we've learned what the concept of a mole is, the next thing we need to be able to do is to calculate the number of moles of a given substance. And once we know the molar mass of a substance, that's something we can generally do fairly easily. So on our previous slide, we had figured out the molar mass of potassium chloride is 74.551 grams. Now, what if instead of 74 grams, so if we had that exact amount, we know it's 1 mole. If we had double that, we would know it was 2 moles. But what if it's some, random amount? 8.0 grams of KCl. How many moles is that? Well, we use our molar mass as a conversion factor. And we're going to put the unit we want to end up with on top, the unit we want to get rid of on the bottom. So grams on the bottom, moles on top. So 1 mole, 74.551 grams. And remember, as you're doing any of these calculations, you always want to factor in significant figures. And we get that our 8 grams of potassium chloride is equal to 0.11 moles of potassium chloride. So let's do another example. So let's say we have 7.53 grams of calcium carbonate. We want to convert that to moles. So take a moment and see if you can first determine the molar mass of calcium carbonate. To do that, you're going to want to look up the mass of calcium, the mass of carbon, and the mass of oxygen, which you'll multiply by 3. And as a result, you should get somewhere around 100.09 grams per mole. If you get something that's a little bit different, don't be concerned. And by a little bit different, I mean a little bit different past the decimal point. It could very easily be, sometimes these molar masses get adjusted on periodic tables over time as more information is learned about these elements. So as long as you're working with a number that's around 100, you should be in good shape. And then we just take our 7.53 grams times 1 mole over 100.09 grams. And we get 0.0752 moles. Now, we can also go the other direction. So let's try this one. Find the mass of 0.87 moles of glucose. And glucose is C6H12O6. So again, you go back to your periodic table, you find carbon 12.011. Since there's 6 of them, we're going to multiply that by 6. For hydrogen, 1.008 times 12. And for oxygen, we can see that it's 15.999. And there's 6 of those. So we're going to do each of those and add them together. And we get a total of 180.16 grams per mole. Now we're just going to convert back the other direction. So 0.87 moles. Now we want to go from moles to grams. So we're going to put grams on top, moles on the bottom. Giving us 157 grams of glucose. So why do we need to be able to do this, these grams to moles conversions and moles to grams? Well, as we said when we introduced these chemical equations, what we will find is we have to work with moles in order to do the calculations. We can't use grams because those gram quantities don't necessarily, they don't correspond to number of molecules in the way that moles do. So we have to first calculate number of moles, because number of moles is a representation of the number of atoms or of the number of molecules. And then we can do calculations from there. And just to demonstrate what I'm talking about, we could also ask here, this 0.87 moles of glucose, how many molecules of glucose? So 0.87 moles times, and how do we find that? Well, if you recall, we said that 1 mole of anything is equal to 6.02 times 10 to the 23rd of that object. So all we have to do, we take our 0.87 moles, multiply by Avogadro's number, and we get 5.2 times 10 to the 23rd molecules of glucose. And here again, we see why we use moles and not molecules, because talking about 0.87 of a mole, which, as we saw on our previous page, referred to about 157 grams. Those numbers aren't too bad to work with. But if we had to think about it in molecules all the time, now we're talking about 5.2 times 10 to the 23rd, and that's not such an easy number to work with. So as we continue to work through this chapter, we'll continue to get more practice with converting from moles to grams and back and forth, and then we'll start to use that in some more complex situations.